Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Maarten Grootendorst. Maarten has been one of the most influential leaders in natural language processing, creating BERTopic, authoring hands-on large language models alongside Jay Alammar, as you can see in Maarten's background, and all sorts of other educational efforts and contributions to the field. Maarten was also the 28th guest on the Weaviate podcast, and I'm super excited to welcome him back for the 126th episode. Maarten, thank you so much for joining.
Thank you so much for being here. How many episodes were it? 256? Wow, it's been a while. Amazing.
Yeah, awesome. Well, so I'm so excited to dive into kind of BERTopic and how I think it changes with agents and LLMs and a lot of these new algorithms we're seeing around it. But first, I really wanted to dive into your experience authoring hands-on large language models and just, your experience with that.
Yeah, that was truly an amazing experience, right? So what most people tend to do is they create some online blogs and they push it out, and maybe one or two people check it and say, okay, it looks okay, and everybody can see it for themselves. So it's a very solo project where there's no necessarily any quality checks aside from your own. And now I got to work with, first of all, an amazing co-author, Jay, the illustrated transformer. It's everybody knows that. So a lot to achieve there. But at the same time, there's a lot of opportunity to learn for the both of us, because we both had very different styles of writing, of working. It were similar enough to actually co-author a book together. But, during the process, it's still figuring out, how do you do the visuals? How does it intertwine with potentially the visuals that I created? How do you write code? How do I do it? All of these questions were easily answered, but still something to consider. And so the process of writing something completely different in a way, you're still focused on, of course, writing hopefully good content and hopefully making people happy with what you've created. But doing it together and with a publisher like O'Reilly, experience changes completely. So I would do it all over again if given the opportunity, because also both O'Reilly and Jay, amazing to work with.
Yeah, it's so cool. And we had the chance to host Jay Alammar at our Neuro series, and I met him a couple times here and there with our Cohere Weaviate partnerships. And yes, I guess my question about the book is maybe I'm curious where your head is at on the level of granularity. People generally, you're seeing people working with large language models, like you could go all the way into CUDA kernels, or even if you're fine tuning models with Hugging Face transformers, that's still pretty low level compared to, say, only using black box APIs. And then you have things like DSPy, like the prompt tuning. It's just, I'm curious what level of granularity you're seeing most people going into with language models.
Yeah, it's especially from where we went with the book, our perspective kind of was, okay, everybody who's just a little bit technically inclined or has seen some code somewhere should be able to, at the very least, read this book and understand what's happening, even if it's from a pseudocode perspective, because we didn't really care about making it a necessarily code first book. But, reading the code helps you understand, okay, it works kind of like this, and you don't necessarily have to execute it. It's a very good experience to do so, but you don't have to. And that's where our visual style of explaining obviously comes from. I mean, it's almost 300 visuals are in that book. And if given the opportunity, we would have done more, but there are limits here and there. But what you see, at least what I see in the community, is that people just want to know, okay, how can I use it? And the most basic way of doing that is, like you mentioned, just fine-tuning, using transformers, calling an API, and just getting a feeling of what can it do and can't do. Because there are a lot of things that you have to experience when using these kind of techniques. So people talk about hallucination, but it's different from having experienced it with an actual use case. And that's what we really wanted to focus on, is that intuition. Because when you're working with LLMs, in a way, it makes sense to fine-tune that. And it's interesting. But then a month later, a new model comes out that does better than your fine-tuned model, which is maybe not the best experience. But it's all about having, I think, just experience with all of these techniques, having seen it once, have used it once, understand what it is about, because the field changes so fast that it's very difficult to keep up with the new things that are happening. So we're seeing a lot of different use cases, different techniques, but mostly from people are new to LLMs, want to know a little bit more about them and understand how they work without going too deep into the mathematics behind it.
Yeah, awesome. I think that I really like that point you make about should you fine tune your own model when, say, GPT-5 or Cloud 4.5 Sonnet or however they name it could just have more capabilities, zero shot. But I think eventually it will saturate this kind of like skill, whether it already has or not is and then having that skill will be really powerful. Awesome. So kind of maybe transitioning into what language models can do. I saw you have the topic modeling chapter in the book, and the BERT topic library has just been amazing. I think it's about 3,000 academic citations in about 2 years, which is just like astonishing success. And then
Thank you.
So I really want to just would you mind maybe just kicking it off by explaining how you see topic modeling?
Yeah. So a little bit of background. I am primarily actually sort of a psychologist. So I've master's degrees in psychology, and then I transitioned into this that's called AI field. And almost anything that I do, I can't help it, but I do that from the view of being a psychologist. So especially with something like topic modeling, for me, that is something that is so subjective that a lot of things that you want to do with it actually becomes quite difficult, because people obviously tend to look for, the perfect thing. And then that's very difficult to find, because perfect, especially in the realm of topic modeling, depends on the person saying it. To a certain degree, of course. It's not a completely subjective field, but that's how I view it. So for me, topic modeling in the broader sense of the word is just extracting topics from any given type of data. And typically that's represented by a number of keywords, but it can also be a label, it can be a phrase, it can be a summary. If you want to make it a poem, that's also fine. It's just an aggregation of, a large amount of data. It's nothing more than that. And you can call it topics, but you can call it many different things, also aspects or what have you. So I view that mostly, not mostly, but for a big part, a subjective thing. Because if you have a very large data set and you could potentially extract 1,000 topics from there, and they're all very fine-grained, then I might be very happy with that. But for your particular use case, you might say, okay, but I think there should be 10. Because 1,000 so fine-grained topics, I'm not interested in that. I don't want to separate cars by brands, for example. I just want a topic about cars, and that's it. And both are valid. They're both valid perspective. They're valid in the way they're being used, and they're both use cases are valid. So because of that, it then also becomes really, really difficult to evaluate topic modeling and to work with it. And that's kind of where BERTopic then stems from, is because I had a lot of problem creating one model that everybody would just be happy with. Everybody would just say, okay, this is the best topic model. Because there was always that one person that would then say, yeah, but I'm not happy with the amount of topics, or I want them more fine-grained, or I want them more like this or that, or I want sentiment to be separated by sentiment, or I want no separation by sentiment. Those kind of things made it very difficult. So as a result came BERTopic with the idea of, okay, if you don't want one model, just do anything that you want. Here's a modular technique, and you can do whatever you want, and your interpretation of topic modeling is a good one. So go do that then.
Yeah, amazing. There's so many amazing ideas in it, like the subjectivity, the topic granularity. How do you evaluate topic modeling? Maybe you just want to roll right into how that kind of modularity of BERTopic has evolved with LLMs and agents. And So maybe kind of coming back to when I first was introduced to BERTopic by you, you explained these kind of building blocks of first you're embedding the data, then you have some kind of dimensionality reduction, then you have some kind of clustering, and now you're summarizing the clusters somehow. And so I maybe wanted to kind of challenge the modular viewpoint right away with this kind of there are a couple papers. One is called Topic GPT, another is called TNT LLM, and they both do this kind of let's have an LLM produce the topics instead of using pre-computed vector embeddings. And the idea is basically a prompt that has a list of topics and is saying it looks at the documents either one by one or in a batch. That's the difference between the two papers. And then you're saying should I assign this to one of the documents or should I create a new topic based on this document? So yeah, I just wanted to kind of pick your brain firstly about what you think about that strategy of forming topics.
So to split it up a little bit into two things. So first of all, the evolution of BERTopic. LLMs were a blessing when they first came out because that made BERTopic only stronger. You just tag on an LLM on the top of it, like you mentioned, and summarize the clusters. So that was perfect. And as models improved, so did BERTopic, because in a way that's kind of lazy of me by making it modular. If a new model comes out, a new embedding model, a new LLM, BERTopic suddenly becomes better. So yay. And now we're going into this realm of agents, and now things are starting to shift a little bit, right? So with Topic GPT in the other paper you mentioned, we're now instead thinking about, okay, let the LLM essentially do the clustering. Not entirely, but it's sort of doing the clustering, right? Or at the very least, it's trying to extract the topics from these documents. And you can see that as clustering, but you don't necessarily have to. Just makes it a little bit easier. And I'm not quite sure yet which approach is quote unquote better. On the one hand, I really like embeddings, mostly because they're in a way static. You have them. You have a vector database. You don't have to recalculate them. You have your features. You're done. The heavy lifting is done, so to say. And then you have the LLMs. And if you're not happy with the topics that are being generated, are you then going to do this entire process of running through potentially millions of documents again through an LLM? That seems wasteful. But it's still a very interesting and smart approach, right? Because embeddings can only capture so much information. And LLMs, well, they're still embeddings in a way, they're just larger. But, they typically can do a little bit more, can get a little bit more fine-grained information, can steer it early on in the process. That's interesting because you can also do that with embeddings, but not in a natural language kind of way. I still think that at some point, both techniques should be combined in a way. I really like embeddings, not because of BERTopic. If something else comes along and it takes over the entirety of BERTopic, that's okay. That's good for the community. It's just that embeddings are a great thing to have, and pre-processing documents all over again, that's costly.
Yeah, I think there's so much power to the vector space visualization too that you get, and
that's a big part of it. And just having, so the thing is, if I've already embeddings and I want to create a new BERTopic model or anything else, it really doesn't matter. That's relatively cheap. You can do that really, really quickly and create in a couple of minutes a new topic model. Whereas if you would do the same with, a purely LLM-based technique, it takes a long time. It's relatively costly. You really have to think about, okay, which models am I going to be using for potentially which steps? But it is very cool to see these techniques being used in that way because there's a lot of information still gained there. So I would love to see some sort of guided approach where you use embeddings to create preliminary clusters and have the LLM potentially steer them a little bit to where you want the clusters to end up with based on some natural language beforehand. That is more the type of techniques that I would envision being more lasting. But quite frankly, if LLMs become really, really cheap at some point, then this entire point is moot.
Oh, yeah. I'm distracted by that last point because something we found at Weaviate is we built this thing called a transformation agent. We are able to do a lot of inferences really quickly with this, and so that was one thing that kind of motivated me to look into this, because we can now apply hundreds of thousands of inferences in a few minutes, and so I'm maybe thinking we could go look at all the documents and get feedback on categories from all the documents. And maybe if we could just keep zooming into that, like if LLM inference becomes incredibly cheap, now you've got this kind of like LLM document inspector going through your whole database.
Yeah, that makes perfect sense still, because if inference were cheap, this is something that makes it also easier for the user to steer towards where you want it to be. We mentioned at the start, this entire field is to a certain degree subjective. But then steering the process through natural language actually helps steer your use case in the way where you want it to be. So in that sense, using purely an LLM for this entire process definitely makes sense here. And then maybe embeddings for, as you mentioned, visualization purposes, and to finding maybe the more hierarchical nature of certain aspects of data, although something like Topic GPT, I believe, also does sort of multiple levels. So if inference really becomes really, really cheap, yeah, that would be quite interesting to explore. Also, because if inference is cheap and we're still talking about transformer models, then I'm also wondering, embeddings are being made during this process, right? Isn't there a way to do this simultaneously and then have them enhance each other during this process of training? And you can even focus it as an agent and have a human in the loop to say, okay, you started doing these kinds of topics. Are you happy with the direction that's going in? And then as a user, you can give feedback and say, oh, but I want more fine-grained. I want more abstract topics. I'm more looking for this and this. So yeah, LLMs would be still very interesting to be a little bit more like an agent-based system having in the loop here.
Yeah, that's super cool. And that really helps me bring what makes like an agentic topic modeling is having that maybe tool use of asking for the human input. And I guess kind of on the other end, aside from the cheap LLMs and having the inference be faster, I think already having it be, well, like forgetting about that, and then say having the most capable language model we can imagine, O3 with as much thinking as you want, or however we're doing it. I think about like that task of taking, say, 50 documents and then coming up with categories for it is quite a complex task, because you have, like you kind of mentioned, like topic granularity is one aspect of this, or it could be like it could be a collection of sentences about dog breeds, and maybe within that there's like the high level, like French bulldog compared to a golden retriever, or it could be like health tips. Is like multiple aspects. So I think maybe using the highly capable language model has that kind of like can really take apart, can really disentangle the representation in a way that might be tricky with just embeddings.
Yeah. And now that you mention this, I don't think it's necessary. It's partly, of course, about disentangling this, but it's mostly about, okay, what then to do next with it? Because you can be as fine-grained as you possibly could, but the user wouldn't like that in many cases. So it's still a user-driven application. I think an LLM will never get it right if you don't prompt it well. And the same applies to embeddings. It just creates a representation and that's it. But as a user, you will always have to say, I want the topic creation to go into this direction or into that direction, because there are so many perspectives that you can potentially take when doing topic modeling. So that's why BERTopic, I think, did well, because its modular nature was a user-driven approach. And if you go into the LLM space, that's amazing, because then you can, again, steer into the direction that you want. The only downside of steering is that people aren't good at steering when they have like complete freedom to steer. we like a fixed set of choices. People are not very good with, here are a million choices, choose something. So information overload here and choice overload becomes a real thing. But there is a potential gap there for LLMs to fill. Not sure whether it should be in BERTopic. Can be, but then I have to find more time to actually do stuff. It's still a hobby, right? So outside of work. But yeah, it would be so cool to see more agentic topic modeling techniques.
Yeah, well, you've completely sold me on the human in the loop. Super cool, and I hadn't thought enough about that going in. I guess maybe I want to zoom a little more into topic granularity in the hierarchy, because I've been thinking a little bit about HDB scan versus K-means, and they have a new one called K-LLM means. It's like the way that they've camel cased the M, and it's kind of like. Yeah, like whether I want to have this kind of hierarchical structure, whether I use, say, HDB scan on level 0 to come up with, say, 7 different topics of variable density, and then within the topics I maybe zoom into it with the topic GPT to do fine grained topics. But either case, I have this tree structure of my topics, compared to where I can maybe just cut up the space with K means, and I know that we're kind of violating the density by just cutting it up like that. But then I think about, you could use the LLM to summarize each of the clusters from the K means, and then maybe have some structure about, here are your nearest neighbors to contrast them. So, because I think if you just have like one level, I think the hierarchy adds quite a bit of confusion to it. Yeah, does that make sense?
Yeah, maybe I'm struggling a little bit. So what do you think is then confusing about having that hierarchy in there for the LLM or?
Well, I will say I'm really biased towards I'm really trying to make this show that topic modeling can improve search performance, like recall. And then when I think about having the hierarchy, that requires just like I'm just like in the devil of the details of how to interface this with the LLM querying agent, where I have to like interface the high level filters and the low level filters. So that's definitely one motivation that drives me to want to just have one single level. Then I also kind of think it might be, I think there might be something to, well, yeah, because the hierarchy, I love to read a book that way, have high level descriptions to just help me wrap my head around it. So maybe there's a place for both of these things, or I guess I'm already kind of feeling like I'm at the dead end of trying to evangelize.
No. I don't necessarily think you are. Again, it's just a matter of perspective here with things. I really like what HDB scan is doing, that it finds very specific granular topics. That's very cool, because then it's very easy to build up from there. So I think it's okay to ignore the hierarchical structure from there if it's for a search purpose. That's different, and then you wanted granularity, so that's okay to have it there. I can imagine it, especially if you can do topic modeling fast, because that's still tricky to do. I can imagine if you have those predefined categories and you put that into as metadata in your vector database, search becomes very fast. I can imagine. I kind of assumed that was already there. It seems like this should be something that everybody's already doing, because it's relatively straightforward to do, right?
Yeah, I guess in like one way the embeddings kind of already capture that for a search, and then you wonder like, can the information derived from the topic that is formed from clustering, can that really add more information than the embeddings already captured? Is maybe one way of.
Oh, for me, it's more a speed thing, actually. If you have 1 million documents and you have 1,000 topics, you only have to run the search over the 1,000 embeddings, and then it finds the top 3, and then you pick, the sum of the documents or all of them from those 3 topics, do again an embedding search, and voila, you have only parsed maybe 5% of the data. It seems like this would give huge speed up to search page. Search already quite fast, but still.
Yeah, and that kind of, maybe like one of the themes that Weaviate has been this kind of dynamic indexes. Like we mostly comes out of like resource saving. Like you only have 10,000 documents, so you just brute force it at that level. But once you get to 1 million, you switch on the HSW. Maybe you also want to say use this like IVF cluster index when you have when you want to use this particular kind of search pattern. And Yeah, so definitely a lot to the entanglement with indexing, with the kind of evangelizing of this topic modeling way of searching.
Uh,
Yeah, super. So maybe I did want to kind of transition now into vector space visualizations. Obviously, you've done amazing visuals with explaining concepts in your book, and I guess I just want to talk about, yeah, like how do you present a cluster of points and just communicate what the topic modeling algorithm is able to do?
yeah, that still remains an open discussion and a very difficult use case. Yeah, the basic technique that most people obviously are using because it's most intuitive is just creating a 2D representation using the amazing package that Leyland McInnes created, data matplot, because it's beautiful and you see the structure there. And then it becomes difficult because then you see nice arrows and nice points and nice clusters, but that's again a proxy of what you actually did because you didn't do generally a 2D reduction of the embeddings. It typically is 5 to 10. That works quite well with HDB scan. So how do you then extract the information that is in 5 to 10 of those dimensions, which is quite tricky. So what I did, and that's maybe going a little bit overboard, I just create like 20 visuals of different types of perspectives and representations that I felt like would give more of a view than those very cool looking 2D plots. Because at some point you want to actually go into, okay, but then what does it constitute of? What kind of documents do I find in this topic? And why was it named this way? And the problem with large language models labeling stuff is you have then a string, a nice label, but I don't know how accurate that label is. I don't have any scores given to that label. I don't know if I should trust one label more than another. And that's always something that I found very difficult, which is why I still like doing TF-IDF, bag of words, but also just semantic similarity, just show the scores there to get a feeling of, but this type of information is important within this particular cluster. And that's great because that gives a very intuitive way then also for people to interpret the clusters or the topics that are being created. So again, with human in the loop, it kind of forces people to think about, okay, but what does this topic actually represent? Instead of being, it's not a bad thing, but instead of being lazy by using an LLM, outputting any given label and just assuming it's correct or really represents the ground truth. So to me, there's there's a need for multiple types of visualizations and a need for different perspectives because we simply can't trust any given topic model to be 100% correct. And we don't have any evaluation metrics necessarily to say that they are correct. So you are then responsible for judging the quality of that model. And for me, one of the best ways to do that is just look at your data. And the best way to look at your data is not one visual, there are multiple ones, is inspecting the data and even being involved in the creation process of the topic model, whether that's defining the models in BERTopic or, a human in the loop in the agentic system. The accountability goes back to the person actually doing the modeling.
Yeah, amazing. I guess, yeah, I really like kind of like you might use the bag of words, or sorry, not what do you, word cloud. Sorry, I forgot the word of that, but where you have the word clouds to help.
Oh, yeah, I don't have that actually because that's so misleading. People are very, very bad at judging sizes. So that's, and especially because some words are longer than others. So they seem more bigger. No, that's horrible. No, that's one thing I actually didn't do in BERTopic. I figured no, word clouds are not getting in here, and people still wanted them, which still is understandable if it's just about okay, these words appear in there, and to have a quick intuitive feeling. Oh, these are just important words. When judging the actual values that these words represent, that's extremely misleading. But word clouds are a fun thing.
Yeah, well, I also think kind of something we haven't seen enough of is maybe like bounding boxes around the labels within these. It's mostly just like a points, and they're probably like colored, and maybe think, or even just maybe not necessarily the bounding box, but I think just kind of this interface of having like the points on the left and then some text on the right that explains the cluster. Then kind of, so maybe an idea I wanted to pitch was this kind of like contrastive label descriptions, like I've these are cars, like within cars, these are Mercedes, these are BMW, and like here's the particular difference between them, and that's like a part of the interface is having some kind of like contrastive explanation of clusters.
Yeah, so that's smart. Not just from a UI perspective, but also potentially training, because contrastive learning is just one of the best things people ever invented. I'm over exaggerating here, but this entire LLM field is for big part based on just contrastive learning, and we do the same thing as humans, of course. But for the UI, that would be very cool to implement. I remember that Vincent Warmerdam, who does a lot of Pythonic awesome stuff, created a visualization tool where you can view your clusters, and next to it, when you've selected them, you can see the documents that are in them. But what makes one thing and not another thing, yeah, that would be cool to set side by side. Also, if you do that during potentially the training process. That's kind of what I imagined with the class-based TF-IDF stuff that I did, right? That's a very simplistic, low-level way of approaching that. So what is important in this, but not in everything else. That's kind of the idea here. So you can maybe flip those scores and they have the same sort of thing. But that would be interesting. Yeah, people judge something not just by what it is, but also by what it is not. So, yeah, you're giving me ideas. Don't give me too many. I don't have the time to work on all of this. You do it. You do it.
Well, yeah, I think the class-based TF IDF kind of has that contrastive thing built into it, and it was such a cool. I remember when I was first wrapping my head around this idea of using this like cluster membership as is like the document thing with the TF IDF algorithm was so cool. Awesome. So I really want to kind of transition now. We talked a bit about evaluating topic modeling, and so kind of maybe the theme of our podcast is now revisiting topic modeling 2 years later, and LLMs and agents have made a ton of progress. And particularly one area is LLM-as-Judge, using LLMs to evaluate AI systems. And so I think in topic modeling, you now have a new way of kind of evaluating that subjectivity with the LLM-as-Judge.
Yeah, that's tricky for me, because the LLM then should be given the same perspective as you have. If you can communicate that well, okay, then it's closer to your particular use case. But I don't like the idea of just using an LLM to evaluate with a standardized script any topic model, because it doesn't know what to evaluate for, right? It can evaluate generic things, like is it not a complete horrible model? But if it's good for your use case, then it should know what your use case is and what your criteria are. So if you can communicate that extremely well, and we see the same thing with vibe coding, of course, if you can communicate it very, very well, it makes a huge difference. But the moment you don't, that's where I struggle a little bit. So I do like the idea of LLM as a judge, but just with very strict boundaries and clear indications of what should be evaluated on and what shouldn't be.
Awesome. So I maybe wanted to pit. There's kind of like 3 LLM-as-Judge topic evaluations that I've been using. One is pretty popular, which is topic coherence. You basically say how coherent is this topic. Like the LLM-as-Judge prompt is pretty broadly, how coherent is this topic, and then you give it the topic description, and then you give it a few sample documents. And then 2 others that I'm using that I think are interesting is topic diversity, where you're more so evaluating the populations of topics in their descriptions and just giving it a rating. And then the last one I really like, coming into maybe our earlier topic about cheap LLM inference and applying the inference over all the documents, which, by the way, this topic GPT, TNT, LLM, they both break this into topic generation and topic assignment. So you always have this kind of step in those particular algorithms that aren't going to be using embeddings, but using this kind of classification confidence score where you're outputting a float rating of does the document fit into one of these topics nicely.
Yeah, so especially the former two, so the topic coherence and diversity, were originally just mathematical equations, right? And if you then use LLMs for the same purpose, it kind of makes a little bit more sense, right? Because especially topic coherence, there was one paper, our neural topic modeling evaluation metrics broken. I think it's called something like that, which really showed that topic coherence is not the right metric for neural models. Using it as an LLM, that works generally quite well. But then the question is, and that's interesting to me always. So let's say you have created a topic model, and the LLM judges that model as being very coherent, very, very diverse. But it captures all of the wrong topics that you're not interested in. Something can be coherent and very diverse, but not at all what you're looking for. That's for me is the crux of all of these things. They're not bad per se. It's just a perspective, and its coherence will never be enough, because if it generates 3 topics out of 10 million documents, and those 3 topics are very coherent, nobody will like that, because they're just 3. You need potentially more. In most cases, I haven't seen one where 10 million documents and 3 topics is enough, but it can be. See, that's where the tricky part comes for me, where I'm like, we have all of these very cool evaluation metrics, but by themselves, they're not sufficient to actually do the evaluation in a way that people will think people will be happy with them. And that's everything that we're doing is just to make it better for people, the user experience, the output. And that's kind of where I'm struggling a little bit, because I see the value of using LLMs in this perspective, but I don't see the value of using them when you're just doing standard prompt templates without any fine-tuning for your particular use case. That's kind of tricky. But the fun thing is, though, is when you can do that user interface really easily. So you can potentially say, okay, I want to know the topic coherence, but I also have these 5 additional, let's call them, evaluation metrics that are important to me. They need to be at least that many topics. These topics need to cover at least that and that information. That's where, to me, it gets really interesting and becomes really adjusted to what you want.
Yeah.
And what was the last one again? Something with embeddings.
I just, kind of the side point I was making about the embeddings was how when you use something like BERTopic, you can then assign the topic to all your documents really cheaply because you have the embeddings, compared to these LLM only approaches that now you have to do that LLM inference to assign the topics over all the documents. But like broader as a topic evaluation method, maybe you have the classification certainty score is just like another way of
those kind of things can be used. It's just such a shame that LLMs don't really output any numerical information. They kind of do, of course, and you can see whether the aggregate of token probabilities is high and stuff like that, but it doesn't. It's not focused towards actually creating the model. It's focused towards creating the text rather than the actual topics per se. I am happy to see that the whole separation of topic generation and assignment caught on, because I really tried to do that heavily with BERTopic, because generation can be expensive, but if you then do assignment very, very cheaply, then you can do so many cool tricks there. So it might even be interesting that you can start from topic GPT and then throw those topics in BERTopic and do inference easily, visualization easily, all those types of things. So I'm really happy to see the differentiation between assignment and generation. So that's something I was something that was really, really important to me when creating BERTopic, is that it wasn't one process. So it wasn't generation and assignment necessarily in one. So what BERTopic is essentially doing, it starts actually with assignment, because that's kind of the clustering. You can see that as assigning topics, and then the whole bag of words, LLMs, keyword types of representations. That's generation of topics, because that's where you actually give labels, give names to the topics. And by separating those processes, like completely making them in a way independent from one each other, iteration becomes super cheap. So when you're happy with the clusters, then the representation part, that's cheap. That's so incredibly cheap, because you already have embeddings. You can easily extract bag of words, TF-IDF, semantically inspired similarity searches like keyword extraction from those topics. LLMs, super cheap, because you're not processing all of the documents. You're just processing all of the topics, which is generally like 1% of the data. So by separating these two processes, you get so much freedom in your topic modeling pipeline that people can just tag on different ways to extract and give names to the topics, or do dynamic topic modeling, class-based topic modeling, and one of the dozens of other techniques that were implemented in BERTopic. And seeing that happen in all of these LLM-based techniques, that's very hopeful, because it means that technically, in theory, the entire structure of BERTopic can be used for all of these LLM-based approaches, which means that all of the benefits that you had with something like BERTopic can be new package, can be the same, doesn't matter to me, but they can exist also in the quote-unquote more expensive field of LLMs. Because when you're done generating all of these topics and you potentially have embeddings, you can still do dynamic topic modeling then with Topic GPT. That's actually super simple if you just throw them back in BERTopic. All of these tricks and techniques are generalizable. So I think there's a potentially good future for topic modeling. I think the only downside here is that there isn't necessarily an effort as big as something like BERTopic. And I was lucky with BERTopic. It's the right time, and network effect and stuff like that. And also because I just spent a ridiculous amount of time on it outside of my work. But finding somebody that does that full time for a year or so, creating the perfect framework, that's going to be tricky. I think it's possible, though. I've thought about doing that, but priority of things.
I have one more question about just how you would unify Topic GPT and as the initial topics, but I have to take the debate on that last one of thinking about what future products will look like around topic modeling. And kind of one thing that I've come to is Databricks has this thing called Unity Catalog, which is, I guess there's this, like I kind of came into Weaviate from studying machine learning research. And so I've just kind of been like discovering all these database concepts for like the first time. So I know that this kind of metadata store thing isn't like a completely brand new concept. But then when I think about how AI could transform it, I think about topic modeling and forming these clusters could be like a whole new way of doing data discovery. And that's maybe something that I think could motivate just continued.
Yeah, so I'm still having a little bit of difficulty really understanding where this field might, or let's say should go, because everybody's using it in so many different ways. So what you mentioned is very interesting. There's a lot of database-oriented use cases where something like topic modeling might prove to be useful. At the same time, I'm still seeing a huge amount of use cases around mostly conversational data. So Slack messages, Discord, those kind of things are super hyped, and there's a lot of BERTopic or topic modeling use cases being built around that, because topic modeling is relatively easy, right? We now have a lot of solutions, but data quality always will be the problem. So if you have a Discord thread of messages, you don't know who's responding to who. You need sort of an LLM to really understand, oh, he replied to that person, she replied to him, and that's the structure. And it feels like more and more that's, as we always knew, the data was the issue here, and formatting that in a very structured way makes all of these topic modeling techniques really, really shine. I'm not that familiar with the Databricks product that you mentioned, so I can't comment much on that.
Oh yeah, yeah. It also kind of inspires me thinking about the role of topic modeling in model development. Like I'm training a machine learning model, and I want to see the failures, and I want to have some insight into, or I can imagine just curriculum learning or sampling the batches. Yeah, I think it's definitely a lot of future opportunity for it. I do think that that topic granularity problem is maybe the most unsolved one. But yeah, I'm just kind of going off into.
Yeah, no, and I really get where you're coming from. To me, it's mostly a use case issue, because if I look at the people using BERTopic, for example, it's there's no one target group using BERTopic. It's really strange in a way, and that's what really truly helped me understand this field of topic modeling, because there's social scientists that are not familiar with Python using BERTopic quite heavily actually in their research of social media and stuff like that. That's a large part of it. But at the same time, there are a lot of organizations using it production for ticketing systems, for example, to just have a sense of, okay, what kind of topics are potential issues for us in the last couple of months. At the same time, it's database enhancement of, or at least data enhancement through metadata. So many use cases for topic modeling, which sounds nice, but it's quite horrible, because developing then the product that is BERTopic also becomes tricky, because you have to create something for everyone, which kind of doesn't make sense, right, to do, because your target audience shouldn't be anyone. That's tricky. I hoped to do that with modularity, but it brings its own slew of problems. Modularity isn't necessarily the best thing. Comes back to the amount of choices that you have. That's, but yeah, I'm not sure where this field is moving at the moment. The advent of agents, and especially LLMs, made, well, most people say, okay, topic modeling is done. LLMs is now the future. They can do topic modeling, and that's it. That's not the case. I haven't seen that. I would be fine seeing that, but if you check the downloads of BERTopic, it hasn't slowed down. So the moment it slows down, that's a cool indication, which is fine. But I'm not seeing that happen. So it feels like we're missing something. Maybe UI, maybe human in the loop, maybe, like you mentioned, the granularity problem. I'm not sure.
Yeah, so yeah, I think the modularity of it does help it continue. And mentioning that you could unify these topic GPT methods. I guess I do want to kind of conclude by coming back to that topic. Just selfishly, I always use these interviews
Yeah,
to
no, that's fine.
get
That's
all the
fine.
technical knowledge I can. But I kind of want to talk a little, just continuing on this kind of evolution of applications. I think it started out with looking at like sentiment analysis in tweets or product reviews, support tickets. These were like the most common applications. And that's something I was really, one of the kind of the coolest experiences of my AI career so far has been going to the Berkeley Sky Camp, and I saw the LM Arena particularly. And so this is like their project where they're doing the leaderboard of battling the models. And what was interesting about this, and I'm only citing my own experience because I don't have like a link to share with our audience, but is like the first half they were explaining how they do the preference ranking, and then the second half just completely turned into like a topic modeling talk about what are people asking in the LLMs. And so I think that kind of interpreting how people are using chatbots. I think this, like LLMs, this has become like one of the new applications of topic modeling that is maybe the most common. application.
Yeah, it's good that you mentioned that. I always keep forgetting that one. But LLMs are and especially agents are horrible things in a way. You're trusting, some sort of semi-autonomous system to just do stuff, and sometimes you have no clue how it gets there because of the huge amount of tokens it creates during this process. And I can imagine both there and in chatbots that following these traces of thoughts, reasoning, steps, executions becomes relevant for something like topic modeling. I think topic modeling might be actually a little bit too shallow, maybe for that entire analysis, because if it's traces of actions and consequences, then it kind of becomes another field in a way. The topic modeling would then be an enhancement to that process instead of being, I think, a core focus. It is funny that you mentioned the LLM arena, because I remember it was last year or the year before when I reached out doing the art arena, which was created with in part with BERTopic, creating hard questions and extracting the information out there. It's just fun to see how creative people can be with something like topic modeling and then how it evolves. I never would have imagined actually using it for building, those hard questions for these LLMs, but it's possible. So cool to see.
That even inspires me to ask about another one, which is there are all these like open-endedness is one of these like areas of research, is like how do we have creative AI, and they call these like quality diversity algorithms, or balancing quality with diversity. And so it's like if I have my AI system is creating art, I use this vector space visualization. Some it becomes so useful for just getting a sense of the novelty of the images they're creating. Yeah, and I think that's another super
Yeah,
cool.
I've it's a tricky topic, but it feels like that the more we're using LLMs, the more it becomes a UI problem more than necessarily how these systems work, because it's getting a little bit out of scope. Some of the things that are being created, running 20 agents is cool, but seldom really needed. But if you have a UI that helps you understand how all of these processes work and why they do what they do, it helps people be more involved with the stuff that is being created, right? So that's what I kind of hope to do with BERTopic, by giving modularity, by giving visualizations, creating a sort of UI that helps people. But to me, it feels like, especially that agentic stuff is going more and more in that UI type of direction, because it's cool to see, but it feels like we're really scratching the surface with a lot of these techniques currently. Yeah.
Yeah, that's so exciting. Yeah, I think like kind of like how Cursor had just crushed it with the kind of UI for autocomplete. Um,
Yeah, exactly. That's the thing. It's uh, I don't want to diminish their work, right? But it started out as just a fork of VS Code, and they did something so incredible there that it wasn't necessarily about the technology. They're still using, one of those proprietary models. They have one now, but they didn't necessarily have, their own. It all was about UI, and by nailing that UI, it suddenly became, a unicorn. So it's just amazing to see, yes, what LLMs can do, but the true power lies, I think, in interfacing with people. We are still the thing that makes the world go round. So we should make sure that people are happy.
yeah, amazing. And I just think that this topic modeling, it's just such a powerful way of just understanding large amounts of data. And yeah, so I have to think it has that there's something to be mined in this, and this is motivates my like to do just that. And yeah, amazing. So I did say I wanted to just come back to this technical topic, just just some. I really want to understand when you do topic GPT to come up with some topics, and then you're going to put them back into BERT topic. Because I'm curious how this works with the HDB. Like, would you maybe now use K means or like distance?
Oh, yeah,
Yeah,
yeah, yeah.
yeah.
Yeah, yeah, yeah. Good question. not doing that. So there are two ways of doing this. So what I wanted to do with BERTopic, and I've said it way too many times already, but I wanted to be the framework that can do it all. Not necessarily be the best in everything, but it can do it all. And one of the ways that I envisioned is that sometimes you already have information, you already have topics, or you have classes that you might be interested in exploring further. So there are two ways to approach it using that type of data. You have supervised and semi-supervised BERTopic. Supervised is a hack. It's skipping that first part, topic assignment, because you already did that one. So the only thing it's actually doing is creating those TF-IDF representations and those topic vectors and those kinds of things. So that's a very simple trick to then achieving still a BERTopic model. Because the funny thing is when you're done with the UMAP HDBGAN stuff, you don't need them anymore. You can use the embeddings to do assignments and other types of tricks. So you can truly throw them out. So when you save a BERTopic model, and you do that using save tensors, you throw out UMAP and HDBScan. You don't need it. So that's one of the ways that you can actually then feedback them into BERTopic. And you can then still do dynamic topic modeling, for example, because it's based on the TF-IDF representations, just sliding over time slices. All that HDBScan UMAP stuff is not needed anymore. So that's one way of doing that. And the second way, semi-supervised, well, that's a very cool trick in UMAP where you can do a guided reduction of the embeddings. They essentially have a Y parameter. And you can feed it over there, just feed it back into BERTopic, into the UMAP stuff. The Y are the topics created by Topic GPT, for example. And then it guides the process of dimensionality reduction and indirectly, therefore, also the clustering of HDBScan. Simple tricks, but they work so well.
Oh, that's cool. I've had a hard time recursively subdividing because so UMAP is like relative neighborhood structure, and then you should be able to go into the cluster that one of the clusters found from HDBScan, and then UMAP it again to get new clusters within that one.
Correct. You mean when you think a topic is too broad and you want to slice them up into smaller topics, something like that?
Yeah, I guess.
Yeah, I've seen people do that, but that's tricky. And the reason that's tricky is because HDBScan is parameter sensitive, and for good reason, but it is sensitive. So you have a very small data set where you then run another topic model over, essentially, sort of, and doing that process. I've seen people do it, but it just requires a lot of technical experience, I think. And what I've seen at a couple of organizations, startups implementing BERTopic, is that it's very difficult to understand beforehand what the min cluster size parameter should be of HDBScan. So that's the parameter that essentially tells you the minimum number of documents in a cluster needs to be this amount. It's an interesting parameter because it essentially tells you, okay, I want the clusters to be relatively big or large. That's sort of what it is, but it doesn't tell you how many clusters then will be created. So there's a bit of an experimentation there needed to get exactly what you want. So if you then subdivide a large topic into smaller topics, well, then you have to do a little bit of parameter tuning again, which is not the nicest experience to do. So not sure how to best approach that.
Yeah, that's so cool. I love that insight. That's so cool, like your experience of seeing all these different topic modeling deployments. And that's kind of why I almost want to throw away HDBScan and go to the k-means, is because I don't know how to reason about that min cluster size.
It still kind of makes sense, right, to do something like k-means, especially if you feel like, yes, but I know the number of topics that there should be or there might be. The only problem that I have with something like that, but it's not a major one, a smallish maybe, is that there's just a lot of noise in the topics created, and that's kind of a shame. Especially when you then want to do the labeling of the topics. Okay, what kind of information do you then give to an LLM or another type of system? It might be interesting actually to then do k-means and then filter out the noise and then create the topic representations. Using actually something like HDB scan, because it's still a density-based metric. So you can look at the topics within k-means and sort of throw density-based techniques over there and filter out anything. Oh, that would be cool. You can do something like that. Yeah, do that.
That's so awesome. Well, Maarten, this has been amazing. I've learned so much about topic modeling and the journey of BERTopic, and thinking about how agents will factor into all this is all so exciting. One question I love to anchor the podcast with is kind of asking broadly about what future directions for AI excite you the most?
Agents at the moment. It's not just because of the hype, but because they contain so many elements of this LLM space. So what I see happening a lot of times is that when we're talking about agents, we're talking about these systems that talk to one another. But there's a lot of very cool technical stuff happening in there that almost covers the entire field, right? So multimodal LLMs are prime suspect for agentic systems, small models, distillation, reasoning models, planning, all types of generative models that might be out of the realm of LLMs, might be, because we see them fusing now. So that's also very cool to see. So I'm not just excited by agents because of what they potentially can do. I think they can potentially do a lot, but I really like this field because everything about AI seems to come together there, which feels like, okay, we're now slowly starting to understand more of what we can actually do with LLMs. I still think we're scratching the surface with everything that we're doing, but that's very cool because the stuff that we're doing is already amazing. So if that means that we're scratching the surface, can you imagine if we actually create agentic systems that are somehow better checked, better safeguarded, but more performant than we currently have, smaller models, but still multimodal ones. There's so many cool things happening over there. And I'm saying that partly, and there's the second thing that I'm mostly excited about is that all of these fields are starting to converge. It seems like it's not the case, but it feels that way, right? So why are LLMs now suddenly starting to do diffusion? What's happening over there? And why are diffusion stuff now suddenly auto-regressive, right? It feels like we're nearing these kind of world models, these true foundation models that they won't do that now, of course, not in the near future, but actually represent the world that we live in. So yeah, especially those diffusion LLMs, it was extremely fun to see just text popping up and in a way that also feels more logical, right? I don't always reason from the start. I suddenly skip to the end and go back to the beginning and then follow my reasoning. Doesn't mean we should mimic human thinking, but it's fun to see that sometimes we get closer.
Yeah, I think what I was saying on the whole agent wave is it's so cool how it unifies all these areas of software engineering too, like even like these task queues and just all sorts of things. But this last point about diffusion models hitting LLMs, I think the big exciting thing is it's super fast, right? Um,
Yeah, that speed thing is what turned me off at the start with LLMs. You could see the potential, but with the auto-regressive nature of these models, and especially the attention mechanism, which is getting faster, but it's still the attention mechanism. So we're still having a lot of issues there. I was really excited when Mamba came out, these state space models that's, in theory, infinite context window. But now seeing diffusion coming here and actually potentially creating these faster LLMs, because I want them truly on my cell phone, right? Not in the cloud. I want them truly locally and not eating up all of my RAM when I'm using it. And that's a lot of to ask for. If we can potentially do it, speed. Speed for me is the thing, not necessarily performance. They can do already things that we couldn't ever imagine. Maybe the folks over at OpenAI, but I couldn't. But if we can make them fast, like truly fast, that would be groundbreaking, I think. Yeah.
Yeah, amazing. Well, Maarten, I could just keep, picking your brain about this thing.
Me too. It's fun to do this.
Yeah, well, I really hope we'll have another podcast in the future where we can just, again, reflect on how things continue to advance. Maarten, thank you so much for joining the Weaviate podcast. It's been amazing.
Thank you. It's amazing to be here now for the second time, yes, after almost 200 episodes.